Tonight's homework comes from a handout titled Handout Number 1, Distance equals Rate times Time. And the main part of these problems are opposite direction problems, and that's what we're going to end up seeing for the first type of problem. And so let's take a look at it. And so we have two cars leave town at the same time going in opposite directions. So basically what this looks like is this. We've got a town, and I'll just use a dot to represent that town. And then eventually a car leaves and another car leaves at the same time, and they're going in opposite directions. And so notice that I have the town here. One car is going a little slower, so it's a shorter distance. One car goes a little longer because he's going a little faster. And what they'll do is they'll give you the total distance the cars are apart eventually. 297 miles apart is what it says. And so that's a total distance. And so what you're going to end up doing is you're going to write down a variable to represent one of the distances, like let's say d. And then the other distance is going to be the total, the 297 minus the d. And so from this point, that gives us an idea about how to express that distance in our distance equals rate times time formula. And so let's go ahead and write down our formula. And we'll go ahead and we've got two different cars. Car 1, we'll say, is going d miles. We don't know how far. Now it's just a part of this 297 miles. Now we'll use the slower car here. 44 miles an hour is its rate. Now since they left at the same time, we don't know what that time is. We'll just use a variable like t. So that was car number 1. Let's take a look at car number 2. Car number 2, we said, was an expression, the 297 minus the d. That represents its distance. So one distance was d, the other is going to be the total minus that amount. Well, this car travels a little faster, 55 miles an hour. Well, the time's going to be the same because they left at the same time. So what we're going to do from this point is use substitution. Take that 44t and put it in place of d down below, because that's what d represents, is the distance car number 1 went. So let's rewrite our formula now. It's going to be 297 minus 44t equals 55t. And so from that point, we could do some more opposite operations. We can add 44 to both sides. So when we do that, we end up with a 99. And 99t equals, and then 297. So we'll go ahead and divide by this 99 on both sides, and we end up with 3. 3 hours is the time it takes. Let's see what they're asking for. In how many hours? Yes, that's it. So 3 hours would be our answer. Well, this next problem is similar in a way, except this one's got a little bit more involved. The student is walking and jogging to school each day. So here is, I guess, the home, let's call it H, and then here's college. And what happens is the student averages 5 miles an hour walking. So let's say walking is in the pink here. So this is when it's walking. And then the student realizes, well, I better start moving here. I'm going to start jogging now. And he jogs a certain distance. And so what we want to do is, it says that the total distance, so this is giving us a total again, the total distance here is 8 kilometers. They also give us a total time. See, this takes the students 1 hour to do the trip. So this is distance. Let's draw another one here to represent the time in which it takes. So here's home, here's college. They have the same sort of thing, but this is now time rather than a distance. And so the total distance, or total time, is 1 hour. That's what it takes. Now, the student doesn't just walk for an hour. The student walks and jogs. And so let's go ahead and fill in this part with, this is the student walking here, and then eventually, again, the student jogs a certain distance. Alright, so let's go ahead and write an expression for what's going on here. And so when we're reading it, what are they asking for? How far does the student jog? So they want to know the distance. Far is a distance. And so when we set up our formula, we're going to put our variables for the jogging. So we've got a formula for jogging, just like we had a formula for car 1. And then we're also going to have a formula for walking. And since, again, we want We want the amount of distance they jogged. We're going to put d in place of that distance. Now, how fast does the person jog? Well, right here, 9 kilometers an hour. So 9 and then t. So I always put my variables in what they're looking for. They're looking for the jogging. Now we will write an expression for walking. Well, I called jogging here. Jogging right here is the distance. Okay, so this is the distance jogging. So the distance walking is a subtraction problem, just like this part here. And so it's going to be 8 minus d. So we'll write that down there. 8 minus d. That's the distance the person walked. Now their rate is 5, because that's what it says here, 5 kilometers an hour. Now their time, it took 1 hour, it says. So the student walks and jogs each day. The student averages this amount. The distance from home to college is 8 hours, or is 8 kilometers. It took 1 hour to do the trip. So we're going to write an expression. We use t for the time they jogged, so we're going to do 1 minus t for the time that they walked. So now we're ready to solve. So it's just like the last problem, just a little more involved. Take this 9t, put it in for that d right there. Let's go ahead and rewrite what we've got now. We've got 8 minus 9t equals, and then I'll distribute the 5 over this subtraction. So I've got 5 minus 5t. And so now I start moving some terms around. So I'll go ahead and add this 9t to both sides. And I'll subtract this 5 from both sides. So now I've got 3 equals 4t. So when I divide by 4, well, I've got my time there. 3/4 equals time. Now this is in hours, so 3/4 of an hour. So that'd be 45 minutes we're jogging for. But we don't want that. We want how far from. So what we have to do now is take this 3/4 and substitute it. Put it in for this t to find out what d is. So d equals 9 times by 3/4. So we go ahead and multiply across. Got ourselves 27/4, and then we can go ahead and do some division. So 4 goes into 27 almost 7 times. It's going to be 6 times. And that leaves us with 3 left over, so 6 3/4. So this equals 6 3/4 kilometers. Well, let's take a look at our next one here. Against a headwind, Jeff computes his flight time for a trip of 2,900 miles at 5 hours. So this is against wind. So whenever we're going against the wind, it's going to take us longer to get there. Well, we know what the distance is. It's 2,900. Now the rate, though, since it's against the wind, it's going to be r minus w. R stands for the rate of the plane. W stands for the wind speed. So we're taking the wind speed away from the rate of the plane. Now it took us to do this 5 hours. So put a 5 right there. Well, the next one, the flight would take 4 hours and 50 minutes. So now let's write this as a mixed number, 4 hours and 50/60. So I did that because I want to be in the same unit. I don't want hours and minutes. I just want hours. Now let's write down what the rate is. If the wind speed were half as much, so half wind. And so half the wind speed would be r minus 1/2 w. So it's still against, so that's why it's 1/2, and it's 2,900. So what I'm going to do is I'm going to go ahead and reduce this a little bit, change this to an improper fraction. So over on this side, I'm going to go ahead and get rid of this 5 real quick. Hold on a second here. So what I'll do is I'll go ahead and get rid of this 5 right now, and I'm going to divide both sides by 5. You see, what will happen is these 5s will cancel out over here, and 5 goes into any number that ends in double zeros. So I do that division of 5, and now I've got a new equation of 580 equals r minus w. Now on this side, multiply 4 times 6 and add the 5, you get 29/6. And then this is still this r minus 1/2 w equals 2,900. So again, what I did is I just went 4 times 6 is 24, plus the 5 makes 29 over the divisor of 6. So I'm going to do the same sort of thing. I'm going to get rid of that fraction. I'm going to go ahead and multiply by the reciprocal of this. So this whole thing, this whole equation by 6/29. That'll cancel out this, but I got to do the same thing on this side. So I got to multiply this side by 6/29. Well, see, they made the problem this way so that you could do this. You see how 29 is going to go into 2900 100 times. 100 times 6 makes 600. And this all equals r minus 1/2 w. Well, if you just multiply this side here by maybe like actually, let's do this. Let's multiply this one by 2. And you see what will happen is it'll cancel out that fraction. And so let's go ahead and rewrite that first equation. 580 equals r minus w. And on this side, we'll go ahead and multiply it by a negative, so that'll make this a positive here. This will become a positive w. It'll become a negative 2r, and now it'll equal negative 2 times 600 makes negative 1200. So we go ahead and add that stuff together. We get a negative r, because these will end up canceling. Notice how it's 1 minus 2 makes negative r equals, and then we just have to subtract the 1200 from that 580, and we end up with a negative 620. Well, you just divide by a negative 1 on both sides, and that'll cancel out that negative sign, leaving us with 620 miles per hour. So that would be the speed of the plane in still air. And find the headwind and the plane's airspeed. So we found that. Now we find the headwind. Well, just take this 620 and substitute it in for this r right here. And so what we've got is 580 equals 620 minus w. So subtract that 620 from both sides. And that gives us 40. So it's a negative, but the wind is negative as well. So again, you divide by the negative 1, and it gives you w equals 40 miles per hour. So there it is, the rate of the plane in still air and the rate of the wind. Well, check out part 2 for other problems similar to tonight's homework.